días a todos. Al ingresar a la presente conferencia de la 10ª Feria Internacional, los participantes entienden y aceptan que sus datos personales e imagen podrán ser divulgados por la Universidad de Monterrey para los fines aquí descritos. La sesión será grabada y almacenada para conformar un repositorio que servirá para futura consulta y referencia de la Universidad de Monterrey. Y también podrá ser difundida por la misma para fines administrativos y otros relacionados con la promoción y capacitación por parte de la universidad. El acceso al material y contenido del presente evento no implica una licencia gratuita para su uso, por lo que deberán respetarse en todo momento los derechos de autor. La información compartida no podrá ser transmitida, grabada ni divulgada de ninguna forma a ningún tercero. Las opiniones expresadas en esta sesión son responsabilidad de cada participante. Se solicita realizar este intercambio de ideas y opiniones con tolerancia y respeto. Buenos días a todos. Permítanme empezar a grabar. Buenos días a todos. Muchas gracias. Good morning to all of you. Thank you for being here connected today with us. On behalf of the University of Monterrey, I give you the warmest welcome to the conference that takes place in the framework of the 10th Udem International Fair, China 2020. This time, we have the opportunity to share the topic Driving Cycle Development and Emission Control Road for Road Vehicles, the case of Vietnam, which will be presented by Professor Lee Antoine from the Hanoi University of Science and Technology. You can use the chat enabled to this Zoom session to ask your questions. We'll have time for the question at the end of this talk. Professor Lee is currently the Dean of the School of Transportation Engineering in Hanoi University of Science and Technology. He is Doctor in Internal Combustion Engines and Thermodynamics from Graz University of Energy in Austria. His fields of interest, in which he has published several scientific papers and books, are alternative fuels, engines, fuel consumption improvement methods, emission measurements and emission reduction measures, emission factors, emission models and emission inventories, driving cycle development, and advanced simulation tools for internal combustion engines. He has received several national honors, being the last one the third-class labor order awarded by the government of Vietnam in 2019. I leave you with Dr. Lee. Very welcome.
Hello, everybody. Good morning in Mexican time and good evening in Vietnam time. It is very exciting for me as well. For the first time to deliver a presentation, to Mexico, which is very far, 12 hours different from, Vietnam. So, it is happy that, a little bit about the COVID-19 pandemic. The situation in Vietnam is much better now. And I hope that, the situation in Mexico is also getting better and better. Can you hear me? Okay. Let's say the topic of my presentation is driving cycle development and emission control for road vehicles. The case of Vietnam. The presentation is prepared by myself and also my PhD students, Dr. Nguyen Thị Yên Liên from the University of Transport and Communication. Content of my talk consists of the following items: background of the emissions, overview of vehicle emissions, the transport-related air pollution, transport-related emission control in Vietnam, and then we come up to the driving cycle developments. How to quantify vehicle emissions and how to determine vehicle emission factors and also some some results from our study on driving cycle development. So, for the better presentation, if you would like to interrupt me anywhere to ask any question, please do not hesitate to raise your hand. First of all, let me introduce a little bit about my country, about Vietnam. It is located in Southeast Asia, and let's say that it is the shape of my country is slender, stretching, and in S-shape with more than 1,000 miles long. The capital is Hanoi, and the population, Hanoi is in the north of Vietnam, and the biggest city of Vietnam would be Ho Chi Minh City in the southern part. And the population of Vietnam is approaching 100 million people. And for the transport sector, Vietnam is known for lots of vehicles, a lot, because it is dominated by motorcycles. It is now motorcycles share more than 90% of the total vehicle fleet in Vietnam. And we, with the total motorcycle of 40 million units, but the number of cars is just only 3.5 million. The public transportation is still, a very small percentage of the vehicle fleet, only 0.03% in Hanoi. And, the traffic jam is also one of the big issues recently in the biggest city of Vietnam, including Hanoi, Ho Chi Minh City, Hai Phong, and some other big cities of Vietnam. So it costs, let's say that transport sector is the main sources for the air pollution in Vietnam. And about the automotive industry or automotive market in Vietnam, let's say compared to other ASEAN countries, in ASEAN, Thailand would be the champion in the number of domestic car production and car sales, and the second would come to Indonesia, Malaysia, and Vietnam ranked the fourth, with with about 400,000 car sales and approaching 200,000 car domestically produced every year. So I would say that the automotive industry in Vietnam is just initiating. So it has very high potential. That's why many car makers would like to allocate the factory in Vietnam. And let me move to the overview of the vehicle emissions. In this figure, we can see that we must care about the exhaust emissions, including carbon monoxide, carbon dioxide, particulate matters, sulfur oxide, nitrogen oxides, and hydrocarbon. And of course, we also have to care about the evaporative emissions, including hydrocarbon and volatile organic compound. Together with that, we also have to care about the refueling losses that also cause hydrocarbon and volatile organic compound, and the road suspension wear, produce particulate matters, and the abrasion of tires brakes and clutch produce also PM. And the significant emission from the exhaust, we can see that the emissions sources are coming from industry, from traffic, from domestic heating, for example, and it is due to the transition, and it causes the air pollution and effect to the people and environment. And finally, we have to care about the air quality. It is the concentration of the components in the air which finally sets after transmission when interacting in the specific place. So let's say that topography, meteorology, and physical chemical reactions also contribute to the formation of the air quality, and let's say the air pollution, and it affects directly to the people and plants and also to the environment. And let's say in overall it causes also the climate change. And emission from vehicles, there are many types, and as I already mentioned in the previous slide, so it including the running exhaust, idle exhaust, starting exhaust, diurnals, resting loss, also running losses, tire wear and brake wear. And more detail, the carbon, maybe you already know that carbon monoxide, it is the result of incomplete fuel combustion. Carbon dioxide, the result of complete fuel combustion, and it is not, the toxic emission, but it causes the greenhouse. It is a greenhouse gas and cause climate change. Sulfur dioxide, the volatile organic compounds, it is the result of incomplete combustion of fuel evaporation. And nitrogen oxide and particulate matters. And when we talk about particulate matters, we have to care much in the diesel vehicles than gasoline vehicles. So a lot of factors that affect on the emission, vehicle emissions, like fuels, for example, fuel type and quality of the fuels, the engine, engine technology, I would say, driving modes, vehicle age, inspection and maintenance also affect to the level of emission factors, and of course the ambient condition as well. So let me talk to the transport related air pollution. The road transport is one of the main sources of air pollution. PM emission from diesel engine is one of the big concern of our goal now. So PM10, PM2.5, it is the main concern, and due to the particulate matters that many cities in the world and also some automaker already announced to ban diesel engine from 2025 and 2030. Emissions of precursors that make up the ground ozone. It is a huge problem now and also in the futures. So we have to care about the volatile organic compounds, NOx, and also we have to care about the hydrocarbon as well. So the disease burden caused by air pollution relating to transport and leading to future challenges to our world. And about the transport-related air pollution in Vietnam, the pressures on urban air quality is mainly due to transport activity. At this moment, the transport consumes the third highest energy in Vietnam. It is consumed about 22% of the total energies. This implies that the transport can be one of the main sources causing air pollution. The traffic, it is data come from our recent research that traffic contributes 46% of the PM 0.1 mass. So PM 0.1 is known as nanoparticles. And these are fuel buses and trucks is main emission sources of PM. And how about the emission control in Vietnam? We, let's say, implemented Euro 2 emission standard for vehicles since the 2007, but it is in reality is about 2010s, I would say, for it is important that emission standard or emission control must go together with fuel standard. And so here we also have the refinery stage for Euro 2 fuels that produce domestically Euro 2 until 2018, and from 2019 the Euro 4 fuels is sold in the market, and Euro 5 is also selling somewhere in some petrol stations. And the emission standard is officially regulated Euro 4 since 2017. To 2017, and we aim to implement the Euro 5 in 2021. But it seems to be not easy to implement the Euro 5 emission standard in this year due to the effect of COVID-19 pandemics, and also the problem of upgrading the refinery from Euro 4 fuels to Euro 5. And right now in the market, for the gasoline, we have two types of gasoline. The first one, it is RON 95, and the second one is RON 92. And this kind of RON 92 is the E5 fuels. So it's not pure gasoline, but it is already blended 5% of the ethanol. And how to quantify the vehicle emissions? The total emission is equal to emission factor multiplied with the vehicle activities. So the emission factor unit of gram fuel, gram emission per kilogram fuels, or gram per kilowatt hour of the engine torques, or gram per kilometer travel, or gram per seconds. So the emission factor plays a very important role, and the vehicle activity, it is the consumed fuel total, power demand, vehicle kilometer travel, or idling durations. Yeah, from that, from the vehicle activities and from emission factor, we can calculate the total emissions for one fleet of vehicles, and we can sum it up with other fleet, and we have the total emissions from different vehicle type and categories. So what is the emission factor? An emission factor is a representative values that attempts to relate the quantity of a pollutant released to the environment with an activity associated with the release of that pollutants. For vehicles, as I mentioned before, that the emission factor is has a unit of kilogram per kilogram or gram per kilogram, gram per kilometer travel, gram per kilowatt hours, or gram per seconds. And how is the vehicle emission factor determined? It is, let's say, a very complicated process, and it costs a lot to determine emission factor for vehicles, because it is not only one type of vehicle available on road, but there are many types with many ages, variations. So we have to categorize the vehicles, and from each category we have to take the measurements, emission measurements, and what kind of driving cycle should we use for emission measurements. So there are two ways to measure emission factor. One way is that we have to allocate the measuring systems on board and then go to the real-world driving cycles, but that one is not it costs a lot. So usually the researchers will use the driving cycle. So it is a typical driving cycle we have to develop based on the real world driving data, and then we can use that driving cycle to run the engine or to run the vehicles on the chassis dynamometer. From that we can obtain the emissions and of course emission factor. Yeah. So in this figure, we summarize the approaches to determine the vehicle emission factor. And comparison between vehicle emission measurements methods. There are two ways to measure emission. It is under control condition in laboratory or under real world condition. As I mentioned before, that under the real world conditions, low measurements, accuracies, and repeatability, because it is the real world conditions. So it changes a lot due to, for example, traffic conditions, due to the ambient conditions, and also due to the driver behaviors. The collected emission data are used to identify gaps in emissions model. And in laboratories, it is usually sometimes like a type approval test. So study the vehicle emission characteristic or access emission control technologies. Emission measurements data collected from dynamic tests or dynamometer tests on dynamometers can be used to develop emission models. So we can use some software like Copilot or move under the control conditions. So become an ideal approach for fuel for emission factors development when representative the real-world driving cycles are selected. It is also mentioned in the Franco 2013. So since then, anyone has a question?
I think we will wait until you finish, but go ahead. You can continue and we'll ask you the questions at the end.
Okay.
Thank you.
Yeah. So in order to, let's say, to conduct the emission measurements in the laboratory, we need the driving cycle. And here we can say that it is a transient driving cycles. It is a vehicle speed over times. So we can see that the speed fluctuate a lot. And this one is obtained from the real world driving conditions. So and there is also polygonal driving cycles. It is like NEDC, the new European driving cycle for the passenger car and light duty vehicles. So a driving cycle commonly represents a set of vehicle speed points versus time, used to assess fuel consumption and pollution emissions of a vehicle in the normalized way so that different vehicles can be compared. So there are two types. The first one is transient driving cycles. It's like US FTP cycles and the Melbourne peak cycles, for example, and modal or polygonal driving cycles like Japanese driving cycle or EC cycles from Europe. Legislative and non-legislative driving cycles. The legislative driving cycle provided to governments for motor vehicle emission control, and non-legislative driving cycle developed primarily for the estimation of exhaust emission and fuel consumption. Let's say for the non-legislative driving cycle, we can use it for for conducting a research, for example. And for the legislative driving cycle, like Vietnam, we use the European driving cycle. So it is a type of polygonal driving cycle for light duty vehicles and passenger cars. But now for motorcycle, we use the world harmonized driving cycles, and and for the heavy duty vehicles, we use both stationary driving cycles and also transient driving cycle. The construction methods for driving cycles, there are three main steps in the driving cycle development. The first one would be route selection. So we have to select the route for implementing the purchasing method on the real world driving behaviors. Then the real world driving data collection And then from the data collected, we can analyze and develop the driving cycle. The studies are often different in the data collection and cycle construction methods. Two main approaches in driving cycle development. It is based on tip snippets or microchips, or based on Markov theory. And Markov theory is quite popular method to develop the driving cycle. And the final part is our study of driving cycle development. Let's say in 2011, a little bit earlier in 2008, I myself developed a driving cycle for motorcycle. And then in 2011, I support to one other teams in Hanoi to develop the driving cycle for motorcycle and light duty vehicles in Vietnam. And in 2013, I published a paper on the development of driving cycle for motorcycle in Hanoi. And then in last year, I and also my PhD students, she already got PhD, developed driving cycle for buses in Hanoi. And it is route that we select for our data collection. It is 15 routes were selected, and including 3 route types: circular, radial, and also straight. And it is the the area of the Hanoi in the, let's say, in the white Hanoi. We go through also downtown and also go to the suburb of Hanoi with other cities. And collect the real-world driving data. We need the GPS device, and the method is the real-world driving cycle will record it continuously from the starting point 6 a.m. to the finish point of 8 p.m. On weekdays and at weekends as well. And we have to divide the times, for the peak hour in the morning, in afternoon, and also in the office hour, to categorize, the traffic condition. The data were collected in every second to avoid losing information and to make sure that the real-world driving data has the Markov property. So with the data collected from the real world, we have to to processing the GPS data. And the purpose of this process is to standardize data from the step 1, 2, and 3, and remove the random errors related to certain loss of signal data, spiking in the signal, and zero speed drift from the step 4 to step 8, and denoise in the final signal using Kalman filter in the step 9. So limits were stepped up to detect all abnormal points in the speed profile and the acceleration profile. After that, all abnormal points were deleted to create the gaps. It is look like the graph the upper graph, there are some gaps here because we already delete some noise here. And after that, we have to, let's say, estimate the algorithm of missing data here, which was developed by Selesnik and was used to find new data for this gap. So let's say that, you know, some point already generated here. Yeah, to connect the two closest point in this gap. And the result here, it is the percentage of error in the GPS data that summarized in this chart. We can see that, you know, after the correction, the percentage of error is, you know, less than 3%. And you can take a look closer to this, you know, process by taking a look on the GPS data processing for driving cycle development in Hanoi. And there, the driving cycle construction, it is the next step. And here showing the flowchart of driving cycle synthesis using Markov chain in the figure 9 and driving cycle generating algorithm in figure 10 here. I will not go into detail, but someone would like to take a look closely, can contact me or my PhD students, Dr. Lien, for, you know, for any questions. And criteria used to assess conformity, it is using the difference of speed acceleration frequency distribution, SAFD, between the candidate driving cycle and the real world driving cycle. It is calculated by this function, where I is the I being in the SAFD, and the SAFD cycle is the SAFD of the candidate driving cycle, and SAFD data is the SAFD of the collected data. And here's a typical driving cycle for buses in Hanoi developed by us. It is from the real world driving data. We have the duration here, distance, and the average speed. And for the typical driving cycle, the duration is, you know, more or less close to the real world driving data. As we can, you can compare, you know, the distance and also the average speed. Especially the average speed of a typical driving cycle is 16.76 kilometers per hour, which is very close to the average speed, 1659 kilometers per hour of the real world driving data. And this figure shows, figure 11 shows the typical driving cycle for buses in Hanoi. We call SBDC, or Hanoi bus driving cycles. And it is the velocity, vehicle velocity with the versus times. And the SAFD drift is 13.2%. It is acceptable deviation between the SBDC and the real world driving data. And we managed to write a paper in the Journal of Air and Waste Management Association. It is the development of the driving cycle, typical driving cycle for buses in Hanoi. You can find more detailed information in this article, and anyone that would like to have this article may contact me or my PhD student. And another part is development of engine transition cycle. It is regulated in the European regulation that we follow. As I mentioned, that Vietnam followed the European driving cycle. So for the heavy-duty vehicles, due to the test condition, usually the engine is tested, not the whole vehicle is located in the chassis dynamometers, but because for the heavy-duty vehicles, engine can be used either for truck or for buses. So in the regulations, they used to test the engine. That's why the engine have to be located in dyno and operate with a transient or stationary driving cycle. So what is the engine transient cycle? It is the, here it is the, let's say, power or load together with times versus time. An engine transient cycle is expressed in terms of engine speed and load. Yeah, the engine transient cycle is transformed from the transient vehicle cycle. So that means we still have to collect the real world data of that heavy-duty vehicles or buses, and from that data, let's say vehicle versus time, we converted it to the power a load and engine revolution, engine RPM. So here it is a block diagram of the drivetrain model. So we have to transform the driving cycle into an engine transient cycle. So driving cycle is for, let's say, for vehicles, and engine transient cycle is for engine. So we have to use the to transform the drivetrain model, transform the vehicle cycle into the engine speed load pattern for each individual engine. Algorithm. This algorithm is developed by Japan Ministry of the Environment. So you can download this algorithm following this link, and in this figure showing the transient vehicles and characteristic engine speed value, engine full load, power curve, and the gearbox model. To transformation algorithms, from that we can obtain the transient engine test cycle. And it is the some output of our research on the engine speed and torque profile of the transient engine cycle of the buses in Hanoi. The upper sub-diagram illustrates the testing cycle used in chassis dynamometer. It is here. So vehicle speed, and it is normalized engine speed and normalized engine torque. Negative torque values in the sub-diagram denote the motoring segments. And develop the engine stationary cycles as well. You can see this figure. It is quite common for the European stationary driving cycles that use for the engine emission test for Euro for emission standard. The test cycle consists of a sequence of steady state modes. The engine steady state cycles is transformed from the engine's transient cycle. Sorry. The steady state modes are determined based on the joint frequency distribution of normalized engine speed and load in the engine transient cycle. So how to transform engine transient cycle into engine stationary cycles? First, we determine the engine speed ABC by these equations, and then the determination of modes and determination of weighting factors of modes. And here it is more description of NLO and NHI. And we have to establish the full load curve and the calculated value of NHI and NLO. From here, it is let's say the engine for the heavy bus engine, the NHI is 1000 RPM, and NLO is NLO is 1000, and NHI is 2300 RPMs. And from that we calculated then to have an A and B and C. And finally, we come up with this engine stationary cycle for heavy bus engine for buses in Hanoi. And it is the 14 mode stationary driving cycles, and with load percentage versus normalized engine speed. So there are 3 speeds, and A and B and C, and also idle. Country-specific emissions factor for buses in Hanoi. So we have already driving cycle developed, and now we calculate and we make some experiments to aim the emission factor creation for buses in Hanoi. And it is in our study, we have the carbon monoxide emission factor is 1.8 gram per kilowatt hours, while when we run the engine with R49 European driving cycle, the CO is only 0.39. Hydrocarbon is quite similar, the NOx is quite similar, but CO2 is very much different. And and for PM is quite similar. So let's say that the real world driving cycle already implied in the emission factor that given in our study here. So it shows the transient effect of the driving cycles. So that causes very high carbon monoxide with a lot of acceleration and deceleration in the real condition and the real world driving patterns. So that process also produce a lot of CO2 as well. So compared to the standard driving cycles here. And you can take a look in detail in one of our papers written in the environmental science and pollution research, development of the specific emission factor for buses in Vietnam. Okay, let me conclude my presentation that based on the real-world driving cycle data, we developed typical test cycle for bus in Hanoi in order to ready for developing the country emission specific emission factors and determining the country specific emission factor are very good basis for improving the quality of emission inventory, as well as the integrated air quality management in Vietnam. So we already managed to develop the JC dynamometer testing for vehicles, the Hanoi buses driving cycles and Hanoi buses junction cycles for engine dynamometer testing, and Hanoi buses stationary cycles for engine dynamometer testing. Okay, thank you for your attention. And if you have, any quick questions, you can raise your hand now, or you can contact me on my student letters for any comments, questions, or any data that can support for your further research, for example. Thank you very much.
Thank you, Professor Lee. At this point, we'll start with the question and answer section. We have as attendants UDEM students, as well as researchers from different Latin American countries that make part of the research network in vehicles and energy called UDEM. I would appreciate using the chat enabled to this Zoom session to ask your questions or ask for your turn to make them directly. Right now, we have at least three people who wants to make you some questions. Gustavo, please. You are now enabled to talk. Gustavo?
Do you hear me?
Yes.
Yeah.
Okay, I have two questions. One of those is referring to the driving cycle. You were talking about that transient driving cycle versus polygonal driving cycles. I'm not clear if why you have to use polygonal driving cycle versus transient cycles. Does it depend on the kind of car, or if it's a bus or it's a car or something like that?
I would say that transient cycle, it is somehow like real world driving cycles. So we drive the car but following the real world conditions. But the real world condition, that means depends very much on many factors. But we cannot develop one driving cycle for each type of vehicles. So usually for the standardization, they use one simple driving cycle for many types of vehicles. That's why European use the polygonal driving cycle as a simple one, but can use for many type of vehicle in the fleet. For example, for passenger car and light duty vehicles, they use the NEDC. It is a type of polygonal driving cycles. And the transient one use in case that we would like to have very accurate emission factors for one model of vehicles, for example, or one category of vehicles. And in that case, we use the transient one. But for for the emission emission characteristic of the of some type of new vehicles, for example, they would like to obtain a very accurate emissions from the exhaust pipe. In that case, they need the real world driving data. That's why transient cycle is used.
Okay, thank you. And the second question is, you were talking about the Kalman filter and some kind of controls to determine the noising. Why we have to use the Kalman filter, or maybe it is not possible to use another kind of robust approach using, for example, neural control? Why we have to choose? It is a possibility to use another kind of control, like neural control or fuzzy control.
Yeah, sure. We can use another approach as well to avoid the noise of the data, and Markov is one of that.
Okay, but the reason that you choose Kalman filter was something a specific. It's important to use Kalman filter in that case.
No, I would say that you know, many researchers prefer to use Kalman filters. You know, something like maybe it is easy to use or somehow like that. So there is no reason that we have to use Kalman filter only. So
Okay.
you can use other method as well.
Okay, thank you so very much for answering my question. That's all. Thank you.
Thank you.
Thank you. Now we have Felipe with some questions too. Go ahead, Felipe.
Thank you very much. Thank you, Professor Lee, for this presentation, and thank you to the UM for facilitating this space. So I have two questions. One of them is related with what methodology you use to select or to define the driving cycle time length or time duration. So how do you select the correct or a specific value of the time length? That's my first question. And the second one is more general question. The second one is related with what are the gaps or the challenge that we need, do you think we need to face or we can face during the driving cycle construction in order to have more representative driving cycles? So it's basically what opportunities you see for new research in terms of driving cycles.
Okay, let's say that very exciting question. For the length of the driving cycles, we have to base on the real world conditions. Let's say it depends very much on the route that you select for the driving testing. So from the data that you collected, and then you have to analyze it with that data is based very much on the traffic signals, and also based on the traffic conditions as well. And from that you can synthesize to see the different categories of the the velocity that are higher than zeros, and also the distance of stop, the how can I say, the zero speed vehicles at the red light conditions, for example. And from that you collect you divide it into many categories of speed that higher than zero, and also stop conditions. And from that you summarize to get the the length of the driving cycles, the typical driving cycles. That one is not is not so clear to fix whether the driving cycle is 1000 second length or 3000 or more than that. It depends very much on the traffic networks, and it depends on the on the traffic conditions, the red light, let's say the traffic signals sequence in that traffic network as well. And for the second questions, what get for for the future research in the driving cycle developments, I would say that when we focus on let me say that driving cycle developments is mainly based on the actual driving conditions. So it is very much different from this country to other countries, from these cities to other cities. And it depends not only on the infrastructure of the traffic, but it also depends on the people's characters, driver characters, depends on the ambient conditions as well. And another thing is that you can apply other approach, either to use Markov chains or use other approach to develop the driving cycles. So I think that papers on driving cycle development are still having a lot of room to do. Yeah, and let's say that we can talk more about this. For example, when you would like to develop like some driving cycle for some cities in Mexico, for example, then we can share our experience with each other. Is that okay?
Thank you, Professor.
We have another question from Jose. Jose, are you there?
Yes, hello, Professor Lee. Okay. Yes, I have a very simple question that is about how do you calculate the difference in SAF, the speed acceleration probability distribution. But I will say, since we are short of time, I also would like to know why people continue using motorcycles that use fuels instead of using electric motorcycles, especially when in regions where there are a huge amount of motorcycles. What is the difficulty on that?
Can you repeat again your question? The second one.
The second one.
Mm-hmm.
Yes, I'm wondering why countries or regions that have a huge amount of motorcycles continue using motorcycles fueled with gasoline or any hydrocarbon, gasoline, instead of using electric motorcycles. The contribution in the reduction of emission will be so important. So why people don't change to electric motorcycles?
Mm-hmm. Okay, for the first question, actually, you mean the how can we calculate the SAFT drift, for example, here?
Yes. Being a matrix.
Mm-hmm. So we use this, formula to calculate the SAFT drift.
Okay.
Yeah. So it based on the cycle that the typical driving cycle that you develop, and the data that you collect from the road. Yeah. And from that, we calculate the SAFT. And let's say that the SAFT diff in our case is 13.2%. It is already ideal, because not easy to have it somehow, you know, very close to each other. For the second question.
Yes, could you please change to the slide with the formula while you answer the second question? Yes, thank you. Please continue.
Yeah, for the second question, how don't we change from the motorcycle, conventional motorcycle, to electric ones? Is that right?
That's correct. That's my question.
Yeah, let's say electrification is a trend now for our goal, and Vietnam also joining that. Right now, we have for the total number of two-wheelers vehicle in Vietnam, it is about 40 million two-wheelers, including 2 million electric bike and electric motorbike already. So we aim to, you know, to change from the internal combustion engine motorcycles to electric ones. And Hanoi already announced that in the year 2030, all motorcycles have to change to electric. So that's why, you know, there are right now some automakers and motorcycle makers producing and releasing, you know, and introducing several e-bike and e-motorbike to Vietnam market. And I believe that, you know, the number of e-bike and e-motorbike will be increased very soon. And the, you know, the process of changing from the conventional motorcycles to electric ones is, you know, improving and improving. So, and believe that, you know, the share of electric motorcycle would be like a revolution in Vietnam in the coming years. Okay. And in addition that, you know, in this year, we start to introduce the electric bus to Hanoi and Ho Chi Minh cities. So it is also a very good, you know, how can I say, it is like increasing the awareness of people on using more friendly vehicles that protects the environment.
Okay. Thank you very much.
Thank you.
Okay, thank you very much. Is there anyone else who has a question? Okay, let me share my screen a second. Well, can I share my screen actually, Andrea? Let me share my screen for a while, please.
Yeah, please.
Okay.
I will stop sharing.
Yes, thanks. Okay. On behalf of the University of Monterrey, we thank Dr. Lee for his contribution in this matter that helped us to know more about this Asian country and this research topic. And I want personally to thank Dr. Lee for agreeing to open this conference at this time, since it is almost midnight in Hanoi, so thank you very much for that. In recognition of the participation, we delivered this visual diploma that I will give you later by email to Dr. Lee and Tuan for their contribution to this event. And I thank everybody for attend this conference, and I will ask to Dr. Lee if you can give me a couple of minutes to make sure you meet all of my research team who actually works in the same topic. So I think it was to take a little more words to talk about this interesting topic. So thank you very much to everybody for that.
Thank you very much, and I'm also very happy to have chance to deliver the first talk to one Mexican universities, and it is one topic that I'm focusing now, but I can also deliver some other topics as my research interests you already know. So if you have any inquiry, any request for presentation for the conference somehow in the near futures, you can do not hesitate to contact me or contact to my students.
Sure, thank you. So thank you everybody.